start the recording. Okay, so we are going to start with number 17 if you're following along on the printout that's in the course content folder. Number 16, I'm leaving off of the review and the test, so there will only be actually 24 problems on the review and the test instead of 25, which is still plenty. Okay, looking at number 17, it says find the domain of this rational function. So here's the function that we're talking about, and we're supposed to find the domain of it. And remember, the domain of a rational function has to do with the zeros of the denominator that we need to find, and we're going to find those and then leave those out of the domain, right? Because we don't want to include what would make that denominator 0, right? So x squared plus 8x plus 7 cannot equal 0. So if I wanted to find what makes that happen, there's two options. I can either factor that, it's not a bad factoring problem, or since it is x squared, I can use my quad program to find the zeros. Okay, so if I was going to factor this trinomial, I would use x and x, right? X and x need to go here because that's how you would get x squared. Then I'll be looking for factors of this 7 that add to 8. Well, there's only one way to get 7 by multiplication, 7 times 1, and that does add to 8, so that works out. So 7 and 1, to get positive 8, I need them both to be positive. So here's my factors. What do you do with your factors? You set them equal or not equal to 0. And solve them for the x's. So here I would have to subtract 1s from both sides. So x cannot equal -1. And here I would have to subtract 7 from both sides. So x cannot equal -7. Excuse me. Okay, and this is how this one, once it doesn't ask you on this particular problem to put it in interval notation, it'll ask on the next one. Okay, you would just check x is a real number and x cannot equal -7 and -1. Oh, I must have looked at the wrong one, didn't I? So I guess you need to pick the one. Oh, that's kind of tricky. Instead of putting them both in one, x cannot equal -7 and x cannot equal -1. So pick the one that has the 2 spots. That's kind of tricky. Okay, number 18 is the same kind of problem, except it does want you to write the answer in interval notation. So again, we're finding the domain. We have f of x equals -2 over x squared minus 2x minus 35. So again, I need to find the zeros of the denominator. So x squared minus 2x minus 35 cannot equal 0. So again, I'm going to factor this. If I'm not using my quad program, I'll just factor it. So again, x and x for x squared. I'm trying to find the factors of -35 that will add to -2. So let's see, how do you multiply to get 35? 35 and 1, 7 and 5. So I'm going to use this 7 and 5 pair because I need to add to -2, which means I need the negative to be 7 and the positive to be 5, right? Because I need -2 when I add those two numbers together. So I'm going to have -7 plus 5. So here's my factors that I need to set to not equal 0. And then again, solve them for the x. So here I would add the 7 to both sides. So x cannot equal 7. And here, subtract the 5 from both sides. So x cannot equal -5. Now, this one does want you to write your answer in interval form. So let's see. So what I want to show in interval notation is I want to include all the numbers on the number line from all the way from -infinity to +infinity, except for these two. Okay, which means I would start at -infinity, traveling up the number line. Which one of these numbers would you come to first? You're going to come to the -5 first, then you're in union with. Now you want to include the numbers that are in between these two numbers, because there's several numbers in between there that are okay. So from -5 to 7, again, in union with, and then 7 to +infinity. All right, number 19. Number 19 wants you to list all the asymptotes of the function. And then choose which graph it would represent. So r of x equals 9 over x squared minus 4. So we're going to find the vertical asymptotes and the horizontal. It will have a question about an oblique asymptote. We did not cover those. So anytime there is a question about an oblique asymptote, the answer is there's not going to be one. Okay, so again, if there is a question about an oblique asymptote, there is no oblique asymptotes on any of these that we're covering. Okay, so let's find, remember the vertical asymptotes have to do with the zeros of the denominator that are not also zeros of the numerator. And this one's, I don't have to worry about zeros in the numerator because the numerator is not going to have any zeros since it doesn't have an x in it. So I don't have to worry about that. So the zeros of the denominator will be where your vertical asymptotes are. Okay, so I can factor this. It's a difference of perfect squares. Right, x and x for x squared. Okay, then what are the numbers that are factors of 4 that are the same number? Right, so that's what you're looking at. You're looking for the square root of 4 since it's a difference of perfect squares. So you're going to use 2 and 2. Your signs when you're factoring difference of squares are always different. One positive, one negative. Then set them equal to 0. And solve them for x. So here you would subtract the 2's from both sides. So x equals -2, and here you would add the 2 to both sides. So x equals +2. So that's where your vertical asymptotes are going to be. Okay, we are going to have to pick the multiple choice graph of what that would be. So let's just go ahead and start sketching that out. So here's what all the multiple choice graphs look like. Oh. So the x-axis goes by 2's. So this is 2, 4, -2, -4. The y-axis goes by 1's and goes from 0 to +9 and 0 to -9. Okay, and I'm just going with what the different multiple choice graphs do. So there's vertical asymptotes at x equals 2 and -2. Okay, and again, if these hash marks go by 2's, so there's a vertical asymptote there, and a vertical asymptote there. Now, the horizontal asymptote. Now, remember where that comes from. That comes by looking at the degrees of the top and the bottom of your rational function. So remember, if the degree of the top is less than the degree of the bottom, like it is in this case, your horizontal asymptote is automatically at y equals 0. If the degree of the top is greater than the degree of the bottom, then there is no horizontal asymptote. If the degrees equal in the top and the bottom, that's when you look at the coefficient of the leading terms, and it's whatever that fraction is. Okay, we'll see one of those in just a minute. So the horizontal asymptote of this one is at y equals 0. So when I am looking at these graphs, this knocks out 2 of the options, right? So if I'm looking at these, this one only has that one vertical asymptote, so it's not that one. This one has vertical asymptotes at 2 and -2. This one only has one vertical asymptote, so it's not that one. And this one has both of them. So I'm down to B and D, but when I'm looking at B and D, I need to find another distinguishing mark here that's going to tell me which one of these is. So when I'm looking at this function, what I can tell is, the simplest thing I can tell is where the y-intercept is, right? What does the y-intercept mean I need to do? If you put zeros in place of the x's, which means just right here, it would knock that out, right? So my y-intercept would be at -9/4, which means it's going to cross the y at -9/4, which is -2 1/4. So maybe about right there is where it's going to cross through the y-axis. That's how you know it is D instead of B, because look where B crosses through the y-axis. It crosses through up here in the positive. D crosses through in the negative. So it has your vertical asymptotes in the right spot, and then it has the y-intercept down here at -9/4. Number 20. Determine the vertical asymptotes of the graph of the function. So I've got g of x equals x cubed over 3x cubed minus x squared minus 30x. X cubed. Oh, thank you. So what I need to know is where the vertical asymptotes are. And remember, your vertical asymptotes are where the zeros of the denominator are, as long as they're not also zeros of the numerator. So on this one, I am going to have to pay attention to that rule because the numerator will have something that turns that into 0. What is this? What would turn the numerator into 0? What number cubed is 0? 0 is, right? So that's going to be the 0 of the numerator. So we just need to keep that in mind in case that is also a 0 of the denominator. So what I need to do is factor this, and I do notice they all have an x, right? So I can pull an x out, put in parentheses what is left after I take an x out, which means they're all just going to lose an x since I pulled an x out. So I have 3x squared minus x minus 30. So this factor is going to create a 0. What is this one going to create? That 0. Now I do have this down to squared now, which means I can find the zeros of that part using your quad. So go down to quad. Enter the A, B, and C of that trinomial, which will be 3, -1, and -30. Hit enter. You're going to have to hit it twice to get your fractions. So 10/3 and -3. Are the other zeros. But remember, your vertical asymptotes are only, did he get that? So do we have to write them with commas? So on this one, yes, this one does say, it's already got the x equals there for you. It has this there for you. So yes, you would write just the vertical asymptote numbers separated by commas, but which one of these would not be included? Not this one, right? Since it's a 0 of the numerator. So the only two vertical asymptotes are at 10/3, comma, yes, and -3. All right, on number 21, it says find the horizontal asymptote. Now remember, when you're talking about horizontal asymptotes, you're looking at the degrees. That's when you're looking at the degree of the numerator and comparing it to the degree of the denominator. So this looking at the degrees, that means the highest exponent. So we're comparing the 2 and the 4. So what we're seeing is that the degree of the numerator is less than the degree of the denominator. That automatically means your horizontal asymptote is at y equals 0. Let's look at the other two options of what your horizontal asymptote could be. Let's say your function looks like this. So you would be looking at the highest exponents. So what would this one have been if your degree of the numerator is greater than the degree of the denominator? That means there is no horizontal asymptote. And the last option of something that this could be is like this. So here, if you looked at those degrees and they equaled each other, when they equal each other, that's when you look at the leading coefficients, which are the numbers in front of those leading terms. And it's going to be at y equals whatever that fraction reduces to be. So since that one's 1/1, your horizontal asymptote would be at y equals 1. So again, if the numerator is less than the denominator, it's automatically y equals 0. If it's the other way around, if the numerator is bigger than the denominator, there is no horizontal asymptote. Or if they're equal, that's when you look at the leading coefficients and put them over each other and reduce it. And that is your horizontal asymptote. Number 22. So the answer is 0? Yeah, I was just showing, for instance, if the three different ways it could be. But yes, for this problem, that is the answer. All right, 22. This is the one, 22 and 23 are going to ask us everything about the rational functions. Okay, so let's start off. You have x squared plus 2x minus 15 over x squared plus 8x plus 15 and it's going to ask us domain, vertical asymptote, horizontal asymptote, x-intercepts, y-intercepts, all of that. So remember, what we're going to do first is actually find the zeros of the numerator and the denominator, because that's going to lead us into a bunch of the different answers that we need. Okay, so I could, since they're both quad, right? They're both x squared, I can find the zeros by putting them in my quad program or factor them. They're both pretty simple factoring trinomials. X and x for x squared. Factors of negative 15 that add to positive 2. So let's see, that would be a positive 5 and a negative 3, right? Multiplies to negative 15, yes. Adds to positive 2, yes. So what would the zeros be that came from these two factors? This 0, if I set that equal to 0 and solved it, it would be 3. And this one, if I set it equal to 0 and solved it, it would be negative 5. So there's the zeros of the numerator. Let's also find the zeros of this denominator. Again, it starts off x and x for x squared. Again, factors of 15. But this time I need them to add to 8. So I'm going to use 5 and 3 again, but I need them to both be positive, right? To get to 8. So positive 5, positive 3. So what are the zeros of the denominator going to be? This one's going to be negative 5. This one will be negative 3. So there's the zeros of the numerator and the zeros of the denominator. So could you flip those? Like flip what? 5 times 3 or 3 times? Yes. Yes. Yeah, the 3 and the 5 could be in either spot. This right here? Yeah. Yeah, as long as they're both positive. As long as it does the two things I need it to do, which is multiply to positive 15 or add to positive 8. So yes, I could put 3 there, and 5 there. No big deal, that's fine. So the zeros are still -3 and -5. Okay, so the first thing it asks me is to find the domain and write it in interval notation. And remember what the domain comes from is the zeros of the denominator, and they just need to be excluded from the domain. So -3 and -5 need to be left out of our domain. So I want to include every number on the number line from -infinity to +infinity, except -5 and -3. So I would start at -infinity. Now, traveling up the number line from -infinity, who would you run into first? You would actually run into this -5 first, right? Because it would be more towards -infinity. So I would run into -5 first. Then the numbers between -5 and -3. And then the last part would be from -3 to +infinity. So there's the domain. Then it wants to know where the x-intercepts and the y-intercepts are. So remember where the x-intercepts are. X-intercepts are at zeros of the numerator, as long as they're not zeros of the denominator. So let's see, the zeros of the numerator are +3 and -5, but -5 is also a zero of the denominator, so I don't use that one as an x-intercept, only the +3. Okay, so +3, and I remember, your x-intercept is a point, which means it comes from an ordered pair with an x-coordinate and a y-coordinate. And if we're talking about your x-intercept, your y is automatically 0. Your x-intercept is that +3. So the x-intercept will be at 3, 0. Now, how do we find the y-intercept? The y-intercept comes in when you replace all the x's in the function with zeros. So what happens to this function? Your y-intercept is going to be what's left over after you replace all the x's with zeros. So let's see. This would turn to 0. 2 times 0 is 0. So all I'd be left with is that -15. Down here, if I place a 0 in this x, I would have 0 squared, which is 0, plus 8 times 0, which is 0, plus 15. So this would all be gone. I'm just left with -15 over +15, which is -1. So your y-intercept, again, is a point. So it's got an x-coordinate and a y-coordinate. Your y-intercept, remember, you replaced all the x's with zeros. That's why your x is 0. Your y is what's left over. So it's at -1. The next thing it's going to ask you is, where is the vertical asymptote? Let me erase this part. Now remember, your vertical asymptotes are those vertical lines, all vertical lines, and it's going to want you to write, oh, it's already got the x equals there for you. So the numbers that you're going to use for vertical asymptotes are zeros of the denominator that are not also zeros of the numerator. So the -5 is not being counted. So the only vertical asymptote is at x equals -3. The horizontal asymptote, remember where we're looking. We're looking at the degree of the numerator compared to the degree of the denominator. Since they're both x squared, they're the same. When they're the same, what do you look at? Their leading coefficients, 1 over 1 in this case. So my horizontal asymptote is at y equals 1. Your oblique asymptote, there's not one. There's not ever going to be one on this test. There's never any oblique asymptotes. They always ask you about it on these problems. The answer is always, there's not one. Okay, if you have a horizontal asymptote, you're not going to have a oblique one. Okay, so looking at the graph, let's sketch what we know. Let's see, what are we going by here? Looks like we're going to 10, but we're going by twos. 2, 4, 6, 8, 10, 2, 4, 6, 8, 10, 2, 4, 6, 8, 10. Let's put in our vertical asymptotes, or just the one, right? There's only one at x equals -3. So there's your only vertical asymptote. Your horizontal asymptote is at y equals 1. The graph's going to cross the x-axis at +3. So again, if these are going by twos, it's going to cross the x-axis between 2 and 4 there. And it's going to cross the y-axis at -1. So there's what we know. So looking at our options, look at A, its vertical asymptote. Its vertical asymptote is at +3, right? Where does it need to be? Needs to be at -3. So it's not A. Okay, it is going to be B, but let's look at why it's not C or D. D has the same vertical asymptote as A does, right? It's at +3 instead of -3. So when we come down to these two, I shouldn't have put that mark there. Let's look at the horizontal asymptotes. They both have the right. Oh, I just worked out the wrong thing. Okay, D is still in, right? Then why is it B? Because B, I shouldn't have marked that out. I shouldn't have marked D out. D is still in. But why does D eventually go out? Because its horizontal asymptote was at +1 and it needed to be at -1. So here, vertical asymptote at -3, horizontal asymptote at -1, where they should be. Yes. B, right? Because it had this vertical asymptote and that horizontal asymptote. Oh wait. Am I messing this all the way up? Ah, what should it be? Oh my gosh, let's start over. This graph is right. I'm just saying the wrong thing when I'm picking out my A, B, C, or D, right? This graph.
Okay, I got very confused for a second. I was like, wait, what? Why is she saying that is
so?
Okay.
This graph and match it to the A, B, C, or D, which would be what? D, right? D has the horizontal this horizontal asymptote at +1, this vertical asymptote at -3, like it should.
Like before you even made the graph, I looked down, I was like, oh, it's D, and I marked D, and you're like, no, it's not D, and I was like, wait, it's not D.
I know, I don't know what I'm looking at. I think it's because when I look at stuff upside down, it looks opposite to me. So I'm just totally saying wrong things.
And it further confused me because on the board,
yeah, that's what she's saying. It's her. She's like, "What are you talking about? It's D."
Yeah, and then on the board you have a +1, but you were saying it's -1. I was like, did I miss something? What's happening?
No, you didn't miss something. I missed something. The horizontal asymptote is at +1, which is above, right? It's up in the positive area. So that's why it's D, the letter D as in dog, and not B as in boy. D as in dog.
Okay, because I was trying to figure out what I did wrong.
You're not wrong. I was wrong. So again, this graph is correct. I'm just saying the wrong thing when I'm looking at my A, B, C, and D. All right, the next one is the same kind of problem. We're going to find all of the same information. The function is f of x equals x squared plus 5x over 2x cubed minus 9x squared minus 5x. So again, before I start, since I'm going to be finding all the same information, I'm going to find the zeros of the numerator and the denominator so I can use them throughout the problem. All right? This numerator has the greatest common factor of x, so I can pull out an x. Since they both have an x, I can pull it out, put in parentheses what is left. So if I took the x out of the x squared, I'm just left with x. Plus, if I took the x out of 5x, I'm just left with 5. So let's see, what zeros do those make? If I set this equal to 0 and solved it, it would tell me x equals 0. If I set this equal to 0 and solved it, it would give me -5. So 0 and -5 are the zeros of the numerator. I'm going to start off the denominator factoring the same way, because remember, again, they all still have an x. So if I pull an x out of all of these, they're all going to lose an x, which will turn that into 2x squared now, minus 9x minus 5. So this is going to make the same 0 as this x did. This will create 2 more zeros, right? Since it's x squared, it's going to create 2 more zeros. And since it is x squared, and I don't want to factor that trinomial, I can use my quad program. So the A is 2, B is -9, and C is -5. So the zeros that are created by that factoring are 5 and -1/2. Now, if you could have used the quad here, but remember, because it is x squared, you can always use quad on x squared. Just be careful when you put in your A, B, and C. If you're using quad for this, your A would be 1. Your B would be 5. Then you don't have a constant, so your C would have been 0. So make sure if you're using the quad for that one, that you put in a 0 for the C. So the domain okay, this is a multiple choice, and it just says, it's just, each one is showing what numbers need to be left out of your domain. The numbers that need to be left out of your domain that x cannot equal are all 3 of those, right? X cannot equal 0, x cannot equal 5, and x cannot equal -1/2. Can't equal any of those. The next thing it asks you about is, right, what is the equation of any vertical asymptotes? Now, remember, vertical asymptotes are zeros of your denominator, as long as they're not also zeros of your numerator. So this 0, since it's in the top and bottom, is not a vertical asymptote. Just these two are, right? Because they don't match. They don't have any matches in the numerator. So the vertical asymptotes are x equals 5 and x equals -1/2. It's already got the x equals there for you. So you would just write in 5 and -1/2. it's going to ask you where the horizontal asymptote is. So what are you looking at? You're looking at the degrees, right? The degree of the top is less than the degree of the bottom. When that occurs, your horizontal asymptote is automatically at y equals 0. Then it wants to know the x-intercepts, or x-intercept. The x-intercepts are at the zeros of the numerator this time that are not also zeros of the denominator. So since zeros in top and bottom, this -5 is your only x-intercept. So your x-intercept is at -5, 0. And the y-intercept. So let's think about that. That's if you replace all of the x's in your function with zeros. What would happen there? I'd have 0 squared, which is 0, plus 5 times 0, which is 0. So I put the zeros in for these x's. X cubed, 0 cubed times 2 is still 0, minus 9 times 0 squared is still 0, minus 5 times 0 is still 0. So what happened is you knocked everything out, right? So if you knock everything out and you have a 0 in your denominator, that is telling you there is no y-intercept. So let's sketch this. With what we know, it looks like the x-axis goes by 2s to 8, 2, 4, 6, 8. Then the y-axis goes by 1s to 4. 1, 2, 3, 4, negative 1, 2, 3. So let's see, where are the vertical asymptotes? There's one at 5 and one at -1/2. So 2, 4, 5. -1/2. Why aren't y'all stopping me? Where is this? +5. 2, 4, 5. And -1/2. So -1/2. So there's your vertical asymptotes. Let's see, the horizontal asymptote is at y equals 0, which is right on the x-axis. It's going to cross through the x-axis at -5. So -2, 4, so -5. It's not going to cross the y-axis. Okay, so let's see. What can we knock out? A, B, C, or D? Looking at A has the correct vertical asymptotes, right? It's got one at -1/2, one at +5. It's got the horizontal asymptote. It looks like it crosses the x around 5, and it doesn't cross the y because look at that one little spot where it looks like it's going to cross the y-axis, but what does it have there? It's got a little hole, a little opening, right? Which means, you see what I'm talking about on this little hole? So that means it looks like it's going to cross through the y-axis, but it puts a little hole. So it's not a y-intercept because it's got a hole there. So A looks like a good choice. Let's look at B. B has the correct horizontal and vertical asymptotes, but look, it crosses the y-axis down there at the bottom. It crosses through the y-axis. It doesn't put a hole on it. Same thing with C. C crosses through the y-axis also. But what about D? -1/2, +5. The horizontal asymptote is at y equals 0. It does have a hole. So what's the difference between A and D? So what else can you do here? You could put this in your graphing calculator. Because what do I need to see? I need to see, does the graph have this U shape here?